Morning, ladies and gentlemen. This is Mr. Rowe. We're looking in geometry part A. This is lesson number 19, and we're looking at trapezoids. So trapezoids is one of the special quadrilaterals we're talking about in this lesson. Again, this is information that we have covered in the lesson. Just want you to hear it in words so it can help you understand exactly what we're trying to get you to understand. So let's talk about what a trapezoid is. Trapezoid is a quadrilateral with exactly one pair of parallel sides. So if you take a look at this picture, we have exactly one pair of parallel sides. That's these things right here. See the parallel symbol right there? That tells you that those are parallel. The parallel sides are called the bases. So these are the bases, base 1 and base 2. Of course, base 1 and base 2, it doesn't matter. It's just a label. The non-parallel sides are called the legs. So this will have a lot of the same terminology that you'll hear with some triangles. So these are the legs of the trapezoid. And then the angles that share a base are called base angles. So like this base right here has a pair of base angles in the top corners. And then this base has a pair of base angles in the bottom corners. So those are the base angles. So that's the parts of a trapezoid. And then each trapezoid has two pair of these base angles. Now, let me tell you a little something else that we didn't write here. These consecutive angles right here, because these lines are parallel, will always be supplementary. So if you know the measure of one angle, then you're able to find the measure of the angle beside it, or the consecutive angle to it. So make sure you understand that. That could be something that you could be asked in the lesson. So we have some special trapezoids that we're going to look at. And this is kind of really the focus of the lesson is the isosceles trapezoid. Most of our information is in the lesson is about the isosceles trapezoid. So it is obviously an important trapezoid to understand because it has some properties that we want you to understand. So for a trapezoid to be isosceles, just like for a triangle to be isosceles, two sides must be congruent. And in this case, the legs must be congruent. The legs of an isosceles trapezoid are congruent, just like the two sides of an isosceles triangle are congruent. You'll notice that trapezoids have a lot in common with triangles. So now, based on knowing that we have two congruent sides, we have this theorem. It says if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So, taking a look at that, we got our isosceles trapezoid. And you see these base angles, these are congruent, and so are the ones down here. So they're congruent to each other. So in this case, if I were to give you the measure of one angle, you would have enough information to figure out the other three angles, because these two angles would be congruent. And as we talked about in the last slide, these two angles are supplementary. If I gave you this angle, you could use the fact that this is an isosceles trapezoid to get this angle. Then you can use the fact that this is a parallel or a trapezoid to get that this angle would be the supplement of the given angle. So isosceles trapezoids, very useful as far as getting the information that we need. And then here's another theorem to go with this one. If a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. So here's a picture of that. So again, we know that this is an isosceles trapezoid. So that means these diagonals right here, these diagonals will be congruent to each other. AC will equal DB. And that's what we're going to use for some of our problem solving. Let's take a look at some examples. So here's our first example. We're going to find the value of X. Here is our picture. We have an isosceles trapezoid. We know it's isosceles because of these marks right here. So that means that these two angles right here are what? They are congruent because they have the same measure, the base angles. Since the trapezoid is an isosceles, the base angles are congruent. Because those base angles are congruent, we can set up this equation. 9x plus 4 equals 76, and it's just a two-step equation that we have to solve. Subtracting 4 from each side will give us 72. Dividing by 9 to finish the problem gives us that x equals 8. So isosceles trapezoid. Now, in addition to this, I could also ask you what is the measure of this angle. And you have enough information to tell me because this is a 76-degree angle. And this one must be 76 minus, or 180 minus 76. So let's take a look at our next example. We're going to find the value of x again. So here is our isosceles trapezoid. This time I tell you some information about the sides. Well, guess what? Since it's isosceles, these legs are congruent to each other. So since those legs are congruent, we can set up an equation. 7x equals 2x plus 10. And now solve for x. So we're going to subtract 2x from each side to give us 5x equals 20. Divide by 4 to finish solving here, and we get x equals 4. And again, something else I could ask you here, so make sure you know. I could ask you what was the length of this side right here. So you've got x. You can come here and substitute x in and tell me what the length of the side is. So don't be surprised if that's something you're asked to do in the lesson content. So another special right trapezoid is a right trapezoid. We're just kind of introducing this so you can recognize it. So a right trapezoid has a single pair of right angles. So this is what a right trapezoid looks like. So two right angles consecutive to each other, and then the other two are not right angles. Neither one of these could be a right angle because then we would have a rectangle and not a trapezoid. So understand that it has exactly one pair of right angles. I just want you to be able to recognize this for identification purposes somewhere in maybe some kind of standardized testing situation. So the next big concept that we have for trapezoids is the trapezoid mid-segment theorem. Trapezoid mid-segment theorem. So again, mid-segment should sound familiar because we talked about mid-segments with triangles. Now we're going to apply it to a trapezoid. So if a quadrilateral is a trapezoid, then the mid-segment is parallel to the bases, and the length of the mid-segment is the average of the lengths of the bases. So let's explain that with a picture. So if we have trapezoid ABCD, and we have a mid-segment of EF, just like this. So here's our trapezoid, and here's our mid-segment. You'll recall that a mid-segment, when we talked about triangles, this is also in the lesson content, this connects the midpoints of these legs. So in other words, these two sides have to be the same measure, and so do these two. BF and FC would have to be the same measure. AE and ED would have to be the same measure. So the mid-segment connects the midpoints of sides. So if we have a trapezoid ABCD with a mid-segment of EF, then two things are true. EF is going to be parallel to both AB and DC. So this is parallel to both of these. That's important to know. If you recall from mid-segments, the mid-segment was half the length of the side it was parallel to. Now, a trapezoid is just a little bit different. It's an average. It's the average of the two sides that it's in between. So in this case, EF is equal to half the sum of AB and DC. That's how you find an average. Add two numbers together, divide by 2. So that is basically adding two sides together, dividing by 2. So that is the mid-segment theorem for trapezoids. So let's take a look at an example of how we're going to apply this. We're going to find the value of x. So here is our trapezoid. We have a trapezoid with the bases of 4 and 7x plus 4, and the mid-segment is 3x plus 5. So to find x in this particular problem, we're going to have to set up an equation. So, and after we do that, we're going to have to find A, B, and EF as well. So we're going to do both of these things together here. So to find EF, or to find X, we're going to have to set up this equation. EF, which is the mid-segment, is going to equal half the sum of BC and AB. So how is that going to look? We're going to substitute. EF is 3x plus 5. BC is 4. And AB is 7x plus 4. So now we just need to solve this multi-step equation. And I want you to watch this, maybe watch it a couple times, so you see exactly how I solve this multi-step equation. So I'm going to start off in parentheses by combining any like terms that I have. In this case, I have 4 plus 4, which is 8. So that's going to be my simplification process. The next thing I want to do is I want to cancel out this fraction, because if I distribute, then I'm going to have a bunch of fractions or decimals that I don't want to work with, or at least one. So I can do this a different way to cancel out this fraction. I can multiply both sides by 2. Now what does that do? 2 times 1/2 is 1. So these two are going to cross each other out. So that's what I want to happen. These cross off. And now I have to apply distributive property over here on the next step. So that's going to end up giving me 2 times 3x is 6x. 2 times 5 is 10. These cancel, leaving me just this expression. Now that's going to happen every single time one of these happens. So pay attention, go back and watch that move again. If you don't understand it, make an appointment. I can help you with it. So now we end up with this multi-step equation with variables on both sides. So step 1 in this process is to get the variables on both sides. I'm going to subtract 6x from each side. Why did I subtract 6x? Just because 7 is bigger than 6. That's the only reason I did that. So that leaves us with this one-step equation. And to solve this one-step equation, I'm going to subtract 8 from each side, leaving me x equals 2. So now this is trapezoids from the lesson content. I hope that this helps you understand what we want you to understand and do in the assignment. If you struggle with this content, please let me know in a teacher message or make an appointment for a help session.